So just a little bit of review before we get started. On Monday and Tuesday, we talked about parallel and perpendicular slopes. So your slope equation is right here, and you want to make sure that you have that in your notes. Now what we talked about on Monday and Tuesday was parallel lines have the exact same slope. The lines will never touch. And perpendicular lines meet at a 90 degree angle, which means that they have opposite reciprocals for their slopes. So how we can remember that is we flip it and change the sign. Okay, opposite means we change the sign. Reciprocals means we flip the fraction. So today we're going to take that and add it into writing equations of lines. So the first thing I want you to do is I want you to tell me what the equation for slope-intercept form is. Okay, so slope-intercept form, you should have chosen y equals mx plus b. And then we also learned how to use our point slope form, which was the y minus y1 equals m times x minus x1. So we're going to practice this today. Okay, so these first couple problems should look pretty familiar from Monday and Tuesday. We're going to find the slope, and then we're going to find the parallel and perpendicular slope to that equation. So if my line goes through the points 4, -8, and 12, 5, I want to find the parallel slope and perpendicular slope. Well, the first thing I have to do is I have to find the slope. Remember, when you're given 2 points, you can either use the equation or you can make a table. If I use the equation, my first step is to label x1, y1, x2, y2, and then plug it into your equation that's up here at the top. So we have y2, which is 5, minus y1, which is -8, over x2, which is 12, minus x1, which is 4. 5 minus -8, we can bam that. 8 plus 5 would be 13. 12 minus 4 on the bottom would be 8. So there's my slope. Now the parallel slope, go back up to the top. Parallel slope means it's the exact same. So don't change it at all, just bring it down. Perpendicular slope, remember our opposite reciprocals. We're going to flip it and change the sign. So flip it, 8 over 13. It's positive, so change the sign. It becomes a negative. Okay? Number 2, I want you to do on your own. Go ahead and tell me what the slope is from this equation, and then give me the parallel and perpendicular slope. Okay, so remember y equals mx plus b. Y is all by itself. So which one's the slope? The slope would be the one in front of x. So my slope for this one is -3. Now how do we make a whole number a fraction? Whole numbers are always on top of a 1. So I'm going to put this over a 1. Now my parallel slope should have been exactly the same. Don't change it at all. If you can do -3 or -3 over 1, it means the exact same thing. And then my perpendicular slope, we're going to flip it. So 1 over 3. It's negative, so change the sign, it becomes a positive. Now remember, number 3 is a little bit different. Can I find the slope from an equation right now? No. Which variable do we have to solve for so that we can find the slope? We have to get y all by itself. We got to get it in slope-intercept form. So let's go ahead and solve for y. Remember, we do our dotted line straight down from the equal sign. When we look at the left side, the stuff that's over here with the y. So I need to isolate my variable first. So we're going to get rid of this -6. What's the opposite of minus? We're going to add it. So this is gone. We bring down that 2y. Bring down your 3x plus 6. Y still isn't completely alone. The 2 and the y are multiplying to each other. So what's the opposite of multiplying? We're going to divide. Remember, you have to divide each thing by 2. So that's gone. Y's alone. Remember, we keep the number in front of x as a fraction. And we can simplify the b. All right, so now that y is alone, the number in front of x, we already talked about, is our slope. That's my m value. My parallel slope stays exactly the same, so my parallel slope stays 3/2. And my perpendicular slope, we flip it and change the sign. So that should look very familiar. That was review from Monday, Tuesday. Now we're going to start actually writing equations. Now the writing equations does not change a whole lot from what we had been doing. The biggest thing is you have to pay attention to whether you're going parallel or perpendicular, because we are going to have to change the slope. So on this first one, write an equation of a line parallel. So I'm going to highlight that because I want to remember that it's parallel. Okay, with a line with a slope at -2. Slope is always my m, so I'm going to label it, through the point 4, 7. That's a point, so we're going to call it x1, y1, just like we did before. Now the difference is I want a parallel line. So if my slope is -2, I need to get my parallel slope. So under here I'm going to say parallel slope equals what? Parallel slope we talked about is the exact same slope, so I'm still going to use -2. Now I'm going to ignore this, and I'm going to bring down my point 4, 7 as x1, y1. Now if I'm given a slope and a point, which equation are we going to use? We're going to start with point slope form. So I have y minus y1 equals m times x minus x1. So let's plug it in. We have y minus my y1 is 7, my m is -2, x minus my x1 is 4. Now if the equation asked for it in point slope form, we would be done at this point, but remember we're always going to try to get it into slope intercept form just so we can make sure we have the same answers and practice solving for y. Okay, so I'm going to distribute my -2. So we have y minus 7 equals -2x. And then -2 times -4 would be plus 8. Watch your signs. And now I have one more step to get y alone. We're going to add 7 to both sides. So we have y equals -2x plus 15. Okay, and you can see that this equation has the exact same slope, that -2, as we were given in the original equation. So these two lines would be parallel. Okay, so let's look at number 9. Write an equation of a line perpendicular. So I'm going to highlight that. Perpendicular to a line with a slope of -2. There's my m. Through the point -12, x1, 9, y1. All right, so this time I'm perpendicular. If it tells me that my slope is -2, I want you guys to pause the video and tell me what my perpendicular slope would be. Okay, so your perpendicular slope, what do? We flip it, so this 2 would be over a 1, so flip it 1/2 and change the sign from negative to positive. So now I'm going to ignore my original slope, and I'm going to bring my point down. There's my x1, y1. And then it's the same process that we have been doing. So I'm going to plug it into point slope form. I have y minus my y1 is 9 equals my m is 1/2 times x minus my x1 is -12. Now watch your signs on that one. What do we do with a minus minus? We're going to bam bam it. So now it's a plus. And then we're going to solve for y to get y alone to get it in slope intercept form. So distribute your 1/2. We have 1/2 x. And then what's half of 12? That would be 6. We're going to add 9, same process that we have been doing. Y equals 1/2 x plus 15 again. Okay, and you can see my slope from the original equation right here is -2. My slope in this equation is positive 1/2. So this line would be perpendicular to that original equation or line. Okay. Now these next two are very similar to that. The difference is instead of it telling you the slope, it's going to give you an equation now. So write an equation of a line parallel. Okay, so we need to highlight it. We're parallel to y equals 5x plus 11. through the point 6, negative 2. So if I'm parallel from this equation, the first thing I need to do is figure out my slope. My slope is what? The dude in front of the x. So my slope is 5. So now I need my parallel slope. So we have parallel slope equals what? Parallel slope stays exactly the same, so I bring that 5 down. Now where's this line going? Am I using this original equation? No. If I use this 11 as my b value and I use this same equation again, we're going to have the exact same equation, which, remember from what we talked about before, would be infinitely many solutions. It's the exact same line. We have to come up with a new starting point. So I'm going to completely ignore this whole line. Once I pull that slope out, I'm ignoring that line. And I'm going to use the point that it gives us as my x1, y1. So we're making a new equation that will be parallel to that original equation. So let's plug it into point slope form, or point slope form. So we have y minus, my y1 is negative 2, my m is 5, times x minus my x1 is 6. Bam, bam, our minus minus. We're going to distribute our 5 just like we have been doing. So I have y plus 2 equals 5x minus 30. And then we're going to subtract 2 from each side. So y equals 5x minus 32. Now, if I compare that equation to our original equation right here that we have x'd out, are they the same line? So we're comparing these two equations. Are they the same line? No. They have different starting points. Are they parallel? Yes, because these two slopes are exactly the same. So this would be your answer. Okay, let's do one that's perpendicular. So number 12. I know the numbering's funky on this paper. Okay, write an equation of a line perpendicular to y equals 1/3 x plus 11 through the point 6, negative 2. All right, so perpendicular. The first thing I'm going to do is highlight it. I need to remember that it's perpendicular. Okay, the next thing I need to do, what is the slope of the equation it gives me? The slope of the equation it gives me is the number in front of x, which is 1/3. So I need my perpendicular slope. So what do we do for a perpendicular slope? We flip it, so 3/1, and change the sign. It's positive, I'm going to make it a negative. Now we ignore that original equation and use the point that it gives us. So now we can go through the same process and write a perpendicular equation. So here's my x1, y1, and we're going to plug it in. So y minus negative 2 equals my m, which is negative 3, times x minus 6. Go ahead and solve that down for y. All right, so you should have bam-bammed your 2 to get y plus 2 on the left. And then on the other side, we should have distributed our negative 3 to get negative 3x, and then negative 3 times negative 6 would be plus 18. And then we're going to subtract 2 from each side. So we have y equals negative 3x plus 16. Okay, now you can always double check with that original equation. That original equation's right here. So do they have the same starting point? Nope, so they're not the same line. Compare your slopes. This one's 1/3, this one's negative 3. We flipped it, changed the sign. Those are perpendicular slopes, so we're good. Okay, now the hardest ones that we're going to do are number 13 and 14. This is where it gives you a point to go through, and you have to find the slope. It doesn't give you an equation, it doesn't give you the slope, okay? It's going to give you 2 points. So write an equation of a line through 1, 1, parallel to a line going through 8, 1, and negative 2, 6. That's a lot of information. So first we need a line parallel and through the point 1, 1. So what I just highlighted, we're going to ignore for right now. We're going to come over here to the 2 points that it gives us, and we're going to try to figure out what in the world our original slope even is. So remember, you can either use the equation that's at the top of the page for slope, or you can make a table. So if I use the equation, I have x1, y1, x2, y2. So I have y2, 6, minus y1 is 1, over x2 is negative 2, minus x1 is 8. Or you can make a little table, put your first point, put your second point, and we'll see how they're moving. So 6 minus 1 is 5. Negative 2 minus 8 is negative 10. This simplifies to negative 1/2. Same thing if I made the table. How do I get from 1 to 6? I add 5. How do I go from 8 to negative 2? I subtracted 10. So my y's are on top, my x changes on the bottom, and it simplifies to the exact same thing. Okay, so that's my slope. Now, it gave me my slope here. We found that. Do I need to be parallel or perpendicular to that? Now we're coming back to this highlighted information in yellow. I need to be parallel. So my parallel slope is what? My parallel slope, we keep it exactly the same. So negative 1/2. Now we're going to completely ignore these original points because we want to make a new equation. So they have to go through a different point. So now I'm going to come over here and I'm going to use the point that it gives me. It gives me the point 1, 1. That's what I'm going to use for my x1, y1. So now we can plug it into our point slope form. So we have y minus 1 equals my m times x minus x1. And my x1, whoop, forgot to plug it in. My x1 would also be 1. Okay, so I'm going to distribute that negative 1/2. So we have negative 1/2 x. Negative times a negative is a positive. 1/2 of 1 would be 1/2. I'm going to add 1 to both sides. If you're not confident with fractions, remember you always can use your calculator. You can use desmos.com/calculator. The link is on our homepage. 1 plus 1/2 would be plus 3/2. So this is your parallel equation that goes through the point 1, 1. Okay, it will not be the same line as what we have over here in purple and red, but it will be parallel because our slopes are exactly the same. Okay, let's try this last one. So write an equation of a line through negative 1, 1, or 1, 1, I don't know what I'm reading, that is perpendicular. So remember, we highlight that, we're going to ignore it for now. To a line going through negative 5, negative 2, and negative 4, negative 3. Okay, so what do we have to do first? What do we have to have before we can even think about writing an equation of a line? We have to have the slope. So I'm going to take these 2 points in red and figure out what in the world our original slope even is. So I labeled my points. Remember, that helps us not confuse our numbers together, helps us organize our numbers so we get the right answer. Okay, my y2 is negative 3. My y1 is negative 2. Watch your negatives on this one. x2 is negative 4, and x1 is negative 5. What do I do with a plus or a minus minus? We're going to bam bam it, make a plus. And then the bottom, minus minus, changes the bam bam, we make it a plus. So negative 3 plus 2 is negative 1. Negative 4 plus 5 is 1. What does negative 1 over 1 simplify to? Negative 1 divided by 1 would be negative 1. So this is my original slope. Now, do we need to be parallel or perpendicular? We need to be perpendicular. So I want you guys to tell me what that perpendicular slope is going to be. So ones are a little bit different. We can make this 1 over a 1. And when we flip it, we get 1 over 1 still. Change the sign. It was originally a negative, so now we're going to make it a positive. And 1 over 1 simplifies to 1. Okay, so my perpendicular slope is 1. Now we're going to ignore those original points because we want this to go through a new point. And this new point it's going through is 1, 1, which is my x1, y1. Now we can plug it into our point slope form. So we have y minus my y1 is 1 equals m, which is 1, times x minus my x1 is 1. It's a lot of ones. Okay, we're going to distribute, solve down for y. So we have 1x, 1 times negative 1 is minus 1. Okay, we're going to add 1 to both sides. This 1 is gone, so we have y equals 1x, negative 1 plus 1 is 0. So you can leave it just like that. Or you can put a plus 0 on the end. It is completely up to you. So those are our notes for writing equations of parallel and perpendicular lines.